Fossil fuels are one of the most commonly known energy sources and are stable in many households around the world. There are three different types of fossil fuels: coal, oil, and natural gas. These fuels have been produced over hundreds of millions of years from accumulations of dead matter and exposure to high temperatures and pressure that exist beneath Earth's surface. As seen at the top of the infographic, there are a few advantages and disadvantages of fossil fuel power stations. One advantage is that they have the capacity to generate large amounts of energy in a single location due to their high energy density. In addition, they are also very easy energy sources to find and are still cheap compared to other sources. Also, when coal is used in power plants, it is a very cost-effective energy source. The transportation of these energy sources is also very easy, as they are typically transported through pipes. These power stations can also be built anywhere where large quantities of fossil fuels can transport to, and these sources can be used directly in homes to provide heating. Therefore, these stations have the capability to be built all around the world very easily. These fossil fuels led to several benefits for our energy needs, which is reflected through our constant use of oil to power our cars or gas to light up our barbecues. However, there are still several disadvantages of these fossil fuel stations. They create major pollutants after burning as part of the energy-making process. Along with CO2, SO2 is also formed, which causes acid rain. In addition, coal mining results in the destruction of land and is considered one of the most hazardous jobs in the world. In general, natural gas causes unpleasant odors during transportation that can be hazardous to workers and the environment. One of the main disadvantages of these fossil fuel stations is that their energy is non-renewable. Eventually, these sources will run out and will not be capable of sustaining our society's needs. Overall, these fossil fuels lend several positives and negatives, but still serve to be a common energy source in our daily lives. Moving down the infographic, we can see that the energy density of coal is 24 megajoules per kilogram. For natural gas, it's 54 megajoules per kilogram, and for oil, it is 42 megajoules per kilogram. These numbers show that natural gas has the ability to create the most energy in comparison to the other two sources. In addition, the global use statistics show that oil has a 38% of usage, natural gas has 24% usage, and coal also has 24% usage. Once again, these numbers reflect that oil is the most used energy source in the world, which can easily be seen by our dependence on oil to power our cars. Coal and natural gas are tied in regards to their usage. Next, we can look into the efficiencies of each fossil fuel, which are demonstrated in the Sankey diagrams on the infographic. Coal has a typical efficiency of 39%, as most of the energy is lost to the condenser and boiler. In addition, some of the energy is used back into the system to produce more energy. Oil has an efficiency of 37%, with most of the energy being lost due to heat and exhaust gas. Lastly, natural gas has an efficiency of 43%, with some energy being lost to heat and transmission. Natural gas is the most efficient out of the fossil fuels. Oil and coal have relatively the same efficiency, as their values can vary slightly. Many sources present an 8% range in the efficiency of each of these fossil fuels, but these values represent good amounts for the present-day efficiencies. Next, the generating systems for each fossil fuels and the energy transformations that take place within them are outlined in the following diagrams. These three systems generally have same processes, but with a few differences. A coal power station transforms chemical energy into electrical energy that can be used in homes and businesses. First, the coal is ground into a fine powder and blown into the boiler. The boiler burns the powder, converting its chemical energy into heat energy. Grinding the coal into powder increases its surface area, which helps it to burn faster and hotter, producing as much heat and as little waste as possible. Burning coal also produces ash and exhaust gas, and the ashes are removed by the ash systems and used in materials such as concrete. Next, the gases enter the exhaust stack, which has the ability to filter out any dust and ash before releasing the gases to the atmosphere. Also, burning the coal heats water in pipes surrounding the boiler, which turns the water into steam. The hot steam expands in the pipes, so it is under high pressure when it exits. The pressure pushes the steam over the blades of the steam turbine, causing it to spin, converting the heat energy released in the boiler into mechanical energy. A shaft connects the steam turbine to the turbine generator, so when the turbine spins, the generator also spins. The generator uses an electromagnetic field to convert this mechanical energy into electrical energy. After passing through the turbine, the steam comes into contact with pipes full of cold water. These pipes cool the steam so it condenses back into water. It is then piped back to the boiler where it can be heated up again to keep the turbine turning. Lastly, a transformer converts the electrical energy from the generator to a high voltage in order to transmit electricity efficiently through the power lines to homes and businesses. Later, other transformers can reduce the voltage back down to a usable level. These steps outline the energy transformation that occurs in a coal power station. A gas power station transforms the chemical energy in natural gas into electrical energy as well. First, natural gas is pumped into the gas turbine and is mixed with air and is burned, which converts chemical energy into heat energy. Burning the natural gas produces a mixture of gases called the combustion gas, and the heat makes this gas expand. In the gas turbine, this causes a buildup of pressure. The pressure moves the combustion gas over the blades of the gas turbine, which causes them to spin, converting some of the heat energy into mechanical energy. A shaft connects the gas turbine to the gas turbine generator, so when the turbine spins, the generator also spins. The generator uses an electromagnetic field to convert this mechanical energy into electrical energy. After passing through the gas turbine, the hot combustion gas is piped to the heat recovery steam generator. Here the gas is used to heat pipes full of water, creating steam, before the rest of the gas escapes through the exhaust sac. Just like the coal system, the hot steam expands in the pipe, so when it emerges, it is under high pressure. This high-pressure steam spins the steam turbine, just like the combustion gas spins the gas turbine. Once again, the steam turbine is connected by a shaft to the turbine generator, which converts the turbine's mechanical energy to electrical energy. The steam condenses and is piped back into the heat-recovering steam generator to be used. Lastly, a transformer converts the electrical energy to a high voltage to distribute to homes and businesses. The oil power station's transformation of chemical to electrical energy is very similar to coal and natural gas. First, the oil is piped into the boiler where it is burned, which converts its chemical energy into heat energy. This heat ends up heating water in pipes that surround the boiler, which turns the water to steam. Once again, the hot steam expands and gains pressure in the pipes. The pressure causes the steam to spin the blades of the steam turbine, which converts the heat energy from the boiler into mechanical energy. When the turbine spins, the generator also spins, which can convert the mechanical energy into electrical energy. After passing through the turbine, the steam also condenses and is used again for the boiler. A transformer built into the system converts the electrical energy to a high voltage that is distributed to homes and businesses. On a side note, burning oil produces exhaust gases. These gases are piped from the boiler to the exhaust stack, which filters out any particles before the gases go into the atmosphere. Based off of these power station processes, a general energy transformation can be expressed for all three fossil fuels. As seen from the flowchart, the energy is transferred from solar energy to chemical energy to thermal energy to mechanical energy until it finally produces electrical energy. In summary, fossil fuel power stations release energy by burning it, and this thermal energy is used to create steam that can spin turbines and create electricity. Towards the end of the infographic, we can see the historical and geographical reasons for the widespread use of fossil fuels. The vast usage of fossil fuels began during the Industrial Revolution, when many thought that they were the ideal energy source. Steam trains, the quintessence of transportation during the Industrial Revolution, used coal for fuel to compensate for lack of wood and charcoal. Also, coal was seemingly inexhaustible as a resource and could be easily mined, while still being used in its natural form. In addition, Japanese governments during the Meiji era encouraged the development of coal mines, as they believed coal was synonymous with industrialization. The oil industry began in the mid-19th century and has since risen to global prominence. Kerosene was used for heating and lighting, being the principal product from petroleum. After the development of drilling technology to access oil, the United States gave a new footing to the usage of petroleum as a highly versatile fuel source. Fossil fuels, all of which had easy geographical access at the start of the Industrial Revolution, helped begin industrial revolutions throughout the world and has since transformed economies and societies, leading to the usage of more environmentally sustainable fuel sources. Overall, fossil fuels are very useful energy sources for our society, as seen through the historical and modern-day applications. However, the non-renewable nature of these sources may lend problems in the future, as our society will need to find more sustainable ways to fulfill our energy needs.